Factoring and solving a quadratic with leading coefficient 1. We've seen how to factor polynomials, specifically things that are raised to the second power. When we change the directions to say that we want to solve, we want to end up with a final solution, and that solution relates to what the x-intercepts are if we were to graph the function. So I'm going to start with factoring letter A. I'm going to look at this constant term that's at the end. I want to think about what are the numbers I can multiply together to get me to a negative 6. Because 6 is negative, I know that one of the numbers has to be positive and the other one has to be negative. So the options of two numbers that can be multiplied together to give me 6 are 1 times 6 and 2 times 3. Now, the way I'm going to decide which of those pairs to use is to now look at the middle term. I need these two numbers to combine to give me a negative 5. And again, one of them is going to be positive and one of them is going to be negative. If I were to choose the 2 and the 3, the only way I could get to 5 is if they're both the same sign, that they're both negative. But I need one to be positive and one to be negative. So I think I want to go with the 1 and the 6. I want the overall answer to be negative. So if I do a positive 1 and a negative 6, I think that'll combine together to give me a negative 5, which is that middle term. So the numbers that I want to use are plus 1 and minus 6. There's a special thing that happens when we have a 1 as the coefficient in front of the x squared term. It allows us to set up the parentheses for our factored version by just putting those two numbers that we found over there on the right into the parentheses. So this is my factored version. Now what I'm going to do is use the zero property that tells me I have two items being multiplied together. Here's one of them and here's the other. They're equal to 0. Their product is equal to 0. So that means that one of them, at least one of them, has to equal to 0. So I'm going to split this into two separate equations. X plus 1 equals 0 or x minus 6 equals 0. And then I'll solve each of those separately. So I'll subtract 1, subtract 1. So I'll get that x is equal to negative 1, or on the other side, we'll add 6, and we'll get that x is equal to 6. So these are our two solutions for the original quadratic. Now, in general, we'll see this moving forward, we're expecting to have the number of solutions. Most of the time, it's going to match the exponent. So because the leading term was a 2, we were expecting to find two solutions, which we did. All right, let's move on to example B. I'm going to start by looking at the last term, which is the constant. I want to find two numbers that will multiply together to give me a negative 21. One of those numbers has to be positive and one of those numbers has to be negative. The options of numbers that will multiply together to give me 21 are 1 times 21 or 3 times 7. Next, I'm going to look at the middle term to decide which set of numbers I want. And it looks like I want 3 and 7 because they can combine to give me a plus 4. So I want the 3 to be a negative number and I want the 7 to be positive because that'll combine to give me the plus 4. So again, because I have a 1 as the leading coefficient, I can take these two numbers that I just found and I can put them directly into the parentheses. So I have x minus 3 and I have x plus 7 as my factorization. To solve this, I'll break this up into two separate equations. X minus 3 is equal to 0, or x plus 7 is equal to 0. For the one on the left, let's add 3 to both sides. So we get that x is equal to 3, or we'll subtract 7 from both sides, or x is equal to -7. For example 2, we're going to use the zero product property to solve quadratic equations that can be written as a difference of squares. Looking at example A, we have a perfect square as our first term. The square root of x squared is just going to be x. It's taking the square root of that term there. And then our second term is also a perfect square. It's minus 25. That means that the product has to be a positive and a negative number multiplied together. Taking the square root of 25, I get 5. So I'll put a plus 5 here, and I'll put a minus 5 here. The zero product property tells me that I can split this up into two separate equations. So for my solutions, I'm getting that x is equal to -5 or x is equal to +5. For example B, x squared minus 144 factors into x plus 12, x minus 12. I'll split this up into two separate equations. And then I get my two solutions. X equals -12 or x equals +12.